AI is supposed to live in the cloud, which is awkward because clouds do not have electrical outlets. So where does AI actually live? Inside enormous buildings filled with servers, cooling equipment, transformers, substations, cables, and enough electrical hardware to make the word cloud feel dishonest. And running through much of that physical system is copper. An AI company can launch a new model tonight. A new copper mine can take around 17 years to move from discovery to production. One industry moves at software speed. The other moves at mining speed. And that is AI's copper problem. That quiet mismatch is where a very physical supply problem begins. But do not picture one giant copper cable plugged directly into a robot brain. To find the copper behind AI, follow the electricity. When you ask an AI a question, data can travel through fiber. But the machines processing that question still need power. Inside the data center, electricity moves through cables, bus bars, power distribution equipment, and server hardware. Then keep following the connection. Outside the building are transformers, substations, backup systems, and the wider grid supplying the site. The copper story does not stop at the server rack. It extends through the electrical system required to keep thousands of racks operating together. So why copper? Because it carries electricity extremely well, bends into useful shapes, moves heat, resists corrosion, and can be recycled. Aluminum can replace it in some electrical jobs, fiber can carry data, but neither replaces copper everywhere. Now imagine the world's copper supply as one enormous spool. Power grids pull from it, houses pull from it, factories, vehicles, renewable energy projects, construction, and ordinary electronics all pull from it. Then AI data centers arrive, grab the cable, and join the queue. AI did not create the world's copper challenge, but it has arrived just as many other industries are asking for more. The International Energy Agency expects global data center electricity consumption to roughly double between 2025 and 2030. Electricity use from AI-focused data centers could triple. That does not translate one-for-one into copper demand. But meeting that power demand requires more of the physical system around the servers. Grid connections, transformers, substations, backup power, and electrical equipment. And this is where the two clocks stop agreeing. Ask a software team to improve a model, and the new version may appear before you have learned where all the buttons moved. Ask a mining team for a new source of copper, and the first answer is usually a very long checklist. Geologists must find a promising deposit. Teams then drill it, estimate its size and grade, test recovery, design the mine, study impacts, obtain approvals and financing, and build the mine and processing infrastructure. Finding copper is not the same as having a copper mine. A rock can contain copper and still cost more to process than it is worth. A deposit may be too deep, remote, technically difficult, or unable to secure the infrastructure, financing, approvals, and community relationships needed to operate responsibly. Even after mining begins, copper does not leap from the ground into a data center. Ore must be mined, crushed, ground, separated, concentrated, smelted or otherwise treated, refined, manufactured into useful products, and delivered to the equipment makers building the electrical system. Every step has its own clock. The IEA's 2026 outlook estimates that expected output from existing and announced copper projects could remain about 25% below projected primary supply requirements in 2035, under its stated policy assumptions. That does not mean the planet is guaranteed to be 25% short of copper. It is not an AI-only gap either. Projects can advance, demand can change, prices can influence investment, designs can become more efficient, more scrap can return through recycling. Some applications can substitute other materials. But the projection tells us something important. The current project pipeline may not yet match where wider copper demand is heading. So, what can be done? Use copper more efficiently. Use aluminium or fiber where they make sense. Recover more copper from old buildings, vehicles, electronics, and industrial equipment. Improve existing mines. Develop new deposits carefully. And here is the useful twist. AI may help with geological targeting, process control, maintenance, and grid planning. It cannot generate copper with a better prompt, but it may help us find and use the metal more intelligently. That does not mean digging everywhere tomorrow. Faster supply still has to respect water, energy, communities, environmental impacts, safety, and sound engineering. The answer is to stop pretending digital growth has no physical schedule. The cloud is not weightless. It is a supply chain. Mine, processor, wire, transformer, substation, data center, server, answer. When one link moves overnight and another takes years, the bottleneck is not difficult to find. AI may think at digital speed, but it still has to build at mining speed.